Hello, everyone. Wonderful to see you. Happy Monday of Thanksgiving week. I just want to start off the live stream today by saying thank you. Thank you for all that you do. Thank you for all that you hold, all that you give to your learners, all of the numerous balls that you juggle, all of it on so many levels, on so many scales, in so many different directions and dimensions that you do every day as an educator. Deeply, truly thank you. So I just want you to hear it's at least an N of one who is feeling deep appreciation and putting that out there into the space for you in this week of American Thanksgiving as we pause and reflect and consider our gratitudes. So with that, the thing that I want to chat about and talk about is so we have some data. Now what should we do? What graph type should we choose? And often, almost every week when I am talking with teachers, I ask this question. And almost every week, the answer is, well, I just tell my students for a myriad of reasons, because we don't have a lot of time, because our students haven't yet built up that mental model of different graph choice, because our students love bar charts and we need them to make other things besides bar charts. Absolutely 100%. So part of that is that they've been making bar charts since kindergarten. So they have that mental model. Woohoo, fantastic. But what if we were collecting some data across two different variables and we were doing multiple trials? Fantastic. We've got a range of data that's coming in. Now what? Our students love to go to that bar chart. What could be another option? So we're going to look at some data that a friend shared with me earlier today, actually. And so this is of a quick experiment that students could do where they could look at kind of freshness of soda. So you could pop open a soda bottle and then leave it out. One is directly, you just opened that can of soda. Another is well, it's kind of been sitting on the counter for a while. Maybe you opened it and then class came and then the next class came and then there was a parent call or a parent email you had to address, things like that. So maybe that soda's been open for about 2 hours. And then we're going to put some things inside of those different soda and we're going to see how long they float at the surface before they sink. Okay, and we're going to run a couple different trials, multiple trials. Let's say 5 trials of each of these 2 different soda cans, and we're going to put things inside and see how long they float. Excellent. Okay, so you got it. Are you with me? So we've got our trials and the time that the things float and then the amount of freshness. So these are the variables that we have going in. So our kids have collected the data. A natural inclination for those of us that teach in the upper elementary, middle school, and high school grade levels is to take an average across all of our trials and plot it as bar charts. But I would like to highly encourage us to instead use this amazing graph type that our elementary teachers are working so hard to teach our students in elementary school in math. And it has so much richness and depth into it. And it is called the line plot. Okay, so you see what's going on here? We've got our hours that the soda has been opened. We've got the minutes that these things can sort of float before they sink. And I've got our 2 categories graphed out here. Now, why do I suggest the line plot? Not a line chart, a line plot. Then called a dot plot when we get older. Well, for a wide range of reasons. One of which is you can easily see the range of the data across these 2 categories. Sorry, I'm so bad at doing this backwards. You can see the highs and the lows, the mins and the max. You can see the shape. You can see how spread out your trial, the values of your different trials were. You can generally see kind of where are there clumping and if any points are super far away from the rest of the clump, okay? Well, why is that important? Because all of those things that I just mentioned, the range, the shape, where is there clumping, if there are points far away from the clump, those are all key components to helping our students look at the group of data, considering the freshly opened soda or the soda that's been open for 2 hours as a group, as a sort of section of the system that we are looking at. It is not one number, the average, but rather it is, we have multiple data points from each of those trials, and all of those data points help inform us about the group. And then understanding that we're looking at a group and what that group seems like and what might be typical for, say, soda that was freshly opened in terms of how long things float versus soda that's been opened for 2 hours, is then we can make that comparison between groups. And we've got the nuance and the components of all of our data baked into our visualization. So they're used to making it. They've been doing it since early elementary school, making these graph types. They get lots of exposure to lots of different pieces about the data, and you can move them off of, well, it's just a bigger number. Or the average of, let's see, I calculated it. So like the average of freshly opened is 14 minutes, and the average of 2 hours opened is 7.6 minutes. And so we can move them off of the evidence they're giving us is that 14 is bigger than 17.6. And instead we can have them look at all of the times for the floating when it was freshly opened were higher than all of the times for once that soda has been out for 2 hours. So we are using a visualization type that they're familiar with. We are giving them more information to set them up for more success in terms of analyzing, describing the pattern, and then being able to interpret it. And we are positioning them to think about data in the aggregate. This is the win-win-win. But I know some of our students love the bar charts. Okay, so here would be the opportunity for the bar chart. You can absolutely make a bar chart of the means, but then plot over the values, the raw values as well. Why? For the exact same reason. They can see, oh, let me get it close enough. It's like playing wonky with the light here. They can see the actual values. They can see how spread apart they are. They're no longer just looking at the heights of the bars. We're giving them more information to think in the aggregate. So this is my gift to you. One way that we can help our students think about what graph type to use when they have data is tell them to use the graph type that they're using all the time in math class. You don't really have to teach it. It can be a dot. It can be an X. It can even be a filled in square if you would like, if you want those grids. But each dot represents the value that you have measured. This is a wildly possible opportunity to use this graph type. And I guarantee there's at least one place coming up in the next couple of weeks as we move off of Thanksgiving break into the time warp between Thanksgiving and winter break, where this could be swapped out for a bar chart that you probably have coming up in a unit. So I return to my moment of appreciation and say, thank you, thank you, thank you, thank you, thank you. I hope you all are able to get wonderful rest. Spend time however you would like to spend time this week to rejuvenate yourself, and that you can come back next week feeling a little bit refreshed and rejuvenated for that time warp. I'll see y'all next week. Thanks, everyone. Thank you for all